Sure.
Could you, oops. Hello, everyone. Welcome to another Reactor stream on Twitch. You might also be watching this on YouTube at youtube.com/Microsoft Reactor. We're very excited to have you today. My name is Sarah Guthals, if you haven't seen me on any previous streams. And today I have Francesca with me, this way, Francesca with me.
Hi.
And
Hi, everyone.
Francesca and I are really excited because last Friday, just 3 days ago, we launched a 28-part video series called The Developer's Introduction to Data Science. And we're going to tell you a little bit about that series, a little bit about what you can find in that. Francesca is also going to give you an overview of machine learning and what automated machine learning or AutoML is. And we're going to tell you about the next 7 streams that we have coming up on this channel and how they relate to data science, machine learning, the tools you might want to try out, and the problems that you might want to solve. I do have the chat open here. And so if you have any questions, feel free to ask in the chat. We will be able to answer them here, or we can also answer them on future streams because both Francesca and I will be back over the next 2 weeks, as well as a bunch of our colleagues from around Microsoft. So to get started, Francesca, do you actually want to introduce yourself first?
Absolutely. Thank you, Sarah. I'm very, very excited to be here. My name is Francesca Lazzeri. I'm a cloud advocate at Microsoft, where I lead a team of cloud advocates and developers. My tech focus is on AI and machine learning. So, specifically, I work with a lot of academic institutions. But beside that, I also have a strong passion for art and jazz music. I think that you put here also my Twitter handle. So if you want to reach out, if you want to chat more about machine learning, data science, please feel free to reach me at my Twitter handle.
Awesome. Thank you. And I'm Sarah Guthals.
Thank
I've been
you.
on this Twitch stream a few times in the past, but it's been maybe like a month since I've been here. I'm a principal program manager at Microsoft, working on the academic ecosystems team, which basically means I get to kind of run around Microsoft and anything that I think is interesting and related to kind of teaching and learning and things like that. I kind of dabble in. So if it's K-12 students, if it's adults, if it's professional developers, kind of anyone. I love teaching and learning. It's what I studied in school, particularly teaching and learning tech and computer science. I am a Disney fanatic, and even though I'm not going to be going to Disneyland anytime soon, I still love it. I've got Disney ears up in my wall over here. You can see pictures of us at Disney and Disney resorts. So, we make our home Disneyland. That's totally fine. And I also love just being a mom. I'm a mom to a 2-legged toddler and 4 4-legged children, 2 cats and 2 dogs. So I definitely keep busy, but it's just a lot of fun. And yeah, so we're really excited. I see that there's a question about how we got involved with Microsoft in tech. So we'll try to answer that throughout the stream while we're talking about data science and machine learning. And then if we have, or when we have more time at the end, we'll also talk a little bit about that. So to get started, I really want to talk a little bit about just like why we built this video series. So this is a 28-part video series. It's about an hour and a half in length total. So each video is under 7 minutes, usually around 3 to 4 minutes. And the goal of this series is, my background is I'm a developer. I've been developing for over a decade. I really love developing products, developing projects. I consider them different because products tend to have a little bit more polish. Kind of just exploring new technology and how it can help solve problems. And I remember when I first started coding and I started to realize that pretty much anyone could benefit from understanding the importance or how code works. So the importance of code and how code works. And so I do not mean that everyone should become a developer or everyone should have the skills of a developer. But I do mean that because software is so prolific in our world, that if everyone had a basic understanding of how software was built and how software works, then we'd be able to use it better. And when we had problems, we'd be able to get help more easily. Also, if you never wanted to become a developer, but you wanted to work closely with developers to solve problems, I wanted to say in the real world, I mean, software developers don't live in an imaginary world, but if you wanted to solve more societal problems or problems within your own home or something like that, and you wanted to work with the developer to solve those, if you had some basic understanding of how that code was built, what limitations there might be, but also what possibilities there could be, then that collaboration could be a lot stronger. What I've noticed is in the last, I would say like 4 or 5 years, I feel like maybe like 3 to 4 years, I feel like data science is becoming that next wave, at least for me. My perspective is if all developers, well, all people really, but especially developers, understood the importance of data and data science and machine learning and AI, whether or not we integrate them into our applications, whether or not like we actually know how to do it. If we had a basic understanding of it and we were able to kind of play around with it, even if it was in like a simple toy environment, we would be able to communicate with data scientists better. We would be able to collaborate with data scientists better. And we would be able to know what the limitations of data have and what the opportunities of data has. In addition, if non-developers, if subject matter experts also understood a basic of development and data science, then again, we could have better conversations amongst all three of those kind of pillars. So I feel very passionate about this. I feel very passionate about the importance of data and as it relates to all software development. And I see a question over here, what do we consider data science in the scope of software development field? And you say like this could be a really general question, and I think that's part of the problem is it could be really kind of anything, and that's not a good answer. But that's kind of the same answer that we had with code, right? I think how we define data science, purely if you want to say a data scientist, what they do on a daily basis, they have very specific things that they understand, very specific concepts, very specific types of algorithms, very specific types of actions that they perform, cleaning data, manipulating data, understanding how to do proper data collection, understanding, how to represent data properly. That's a whole part of it. But also just understanding how data, once you have it, could inform something within your application, I think is a part of data science. It doesn't mean you are a data scientist, but it is a part of data science. So I do think when I say data science, it tends to be this catch-all term, because that's the point, is that you should be able to have some kind of resource that starts to give you an introduction into all of the different pieces of it, so that the part that is interesting to you or most relevant to your skills, then you can go off and do a deeper dive. So that's really why we started this series. It isn't all inclusive. It does not give you all of the details. It's not the entire introduction. It was, though, meant to be the first hour and a half, pretty broad, but with also a practical guide of an introduction. And Francesca and I hope to do additional content development for you, including this stream here, the streams we have coming up this week, and also other video series that we hope to build in the near future. I reached out to Francesca and I told her about my passion behind this. And as you saw from her intro, she also has a passion around this. So Francesca, what made you excited about this video series project?
Yeah, so first of all, I think that how you answer the data science question is very, very right, Sarah, because I also see data science as a very broad field. And if I can summarize what data science is, it's really about extracting knowledge from data. And knowledge can be, can be like insights, can be understanding your data better in order to predict something in the future, can be also using your data to do decisions, like informed decisions. So this is, at the end of the day, is the real goal of data science. Yes, so what I really like of this series is how we approach data science. So we don't look at just the most important concepts that are such as how can I clean my data, how can I build my models, how can I deploy my models, all these that are still very important questions. But we also give users and our audience an understanding of what are the tools out there that they can use and how they can use these tools to do data science and machine learning, which is something that, in my opinion, is an aspect that you cannot find everywhere. Like there are some books or some video series that are just about the conceptual or the theory part of data science, and some others that are just practical and just jumping into specific tools. I think that in this 28 video series, we give a very good introduction and very good overview of the most important concept for machine learning and data science, and then how you can use different tools, also open source tools, as you know, like Python, for example, to build your end-to-end data science solution. So this is the thing that I love the most about this series, and also the fact that we are somehow two different people with two different educational background and professional background. However, we have the same passion for data, and we want to build our solution around data. So this is also a great, in my opinion, combination of different perspectives. And I have to say, most of the time, when you work in data science, you find yourself in teams where people have a different expertise. You know, as you said, from software engineers to data engineers to data scientists, and you have to be able to work with all of them. So it's also great from that point of view.
Yeah, no, that's a really great point. You know, there's been this term that I've been using a lot lately, which is that step zero. And I think that's exactly what happened, because when I started to learn about the resources that Microsoft had on data science and machine learning, I started to find a lot of really great either conceptual explanations or practical tutorials. But I had a hard time connecting the two. And that's why I reached out to Francesca. I'm like, look, can you explain to me when I run this line of code, what is happening? So I've been calling that step zero because it's like, you know, the tutorial might be step one. It says open up Azure, or open up VS Code, but what do I need to know before that? What, you know, are there pieces about the business and the problem that we're trying to solve that I need to know before that? So I do want to kind of show you this resource, and this is going to be kind of a one-stop shop resource for you. You can find the URL for it on the screen. It's aka.ms/dev_intro_ds_GitHub. I'll actually put it into the chat as well. And this is really our guide to not only the video series, but also this introduction to data science. And so on here, you're going to find the links to both Channel 9 and YouTube, where you can find our series. Like I said, 28 episodes. They're all under 7 minutes. And what we tried to do here was start with a conceptual understanding of what we're trying to do. So in this video series, I play the role of a developer, which is true. But in this video series, I'm developing a bike sharing app, and I'm trying to figure out how and where data would show up in my story, in my product, in my solution. And so Francesca walks us through understanding different machine learning algorithms, which ones you should use on a conceptual level and why, what automated machine learning is, etc. And then, you know, starting in video 7, I'm like, okay, let's get started. And we open up Azure, create a machine learning resource, set up our local environment with Visual Studio Code. We write some code. We also try out our machine learning code up inside of Azure Machine Learning. So, you know, we show you both. We show you what you could do in a developer environment that you might be used to, like Visual Studio Code. And then we also show you what you could do in the browser. I did want to also mention that, you know, we have a lot of resources on this GitHub repo. We have links to previous series on Python. We do use Python, and we don't teach you Python in this series, so that might be useful. Links to other types of Azure resources, Azure free trials, an overview of what you'll learn, as well as just a bunch of links, all of the links that you might have seen in the videos. And one in particular that I think is really interesting is this data science lifecycle. Oh, and that's not working. That's funny. I have a www in the front of it. I got to fix that. One is this data science lifecycle. And the data science lifecycle kind of talks to what Francesca was saying, which is we not only have data scientists, but we also have developers and subject matter experts that all need to be able to communicate together. And the reason that we all need to be able to communicate together is because the data science lifecycle in its purest form involves information from all parties. We cannot use data to solve a problem if we don't understand what the problem is that we're trying to solve. So on Friday, for example, I'm going to be taking financial data and financial problems that people might be having and using the techniques that we present in this video series on bike sharing to also solve problems in finance. I am not a financial expert, so during the stream on Friday, I'll talk a little bit more about what I can do in the meantime. But the best thing to do would have been to actually bring in a financial expert to explain what the problems are and why those are problems and where they show up, etc. But then there's also pieces around data acquisition and understanding that data scientists have a lot of experience in. There's also pieces on modeling, which is going to be a combination of the data scientist and perhaps the developer. And then the actual deployment into other intelligent applications or web services or things like that is really where you'll want to bring in a developer to actually create that data science solution and bring it in. Sorry about the blurry text. I'll try to zoom in a little bit more. But in any case, that link is here. It's not 480p. Unfortunately, my bandwidth is not the best, so I apologize for that. So yeah, I just wanted to make sure that you had access to this repository because it also has in it all of the code that we wrote for this video series, including how to get started. So the setup includes creating an Azure account, creating your Azure Machine Learning resource, and then also setting up your local dev environment with Visual Studio Code, Python, Anaconda, importing all of the packages you need, and writing the code. Awesome. So, Twitch is rendering 480p. That's so frustrating. I'm so sorry. Mine are set to as best as I can. I think it might be my bandwidth. So hopefully Francesca's slides will show up well. If not, we'll definitely be sure to link to them afterwards. I did get a question earlier. Are we going to mention neural networks at all? In this video series, we won't unless Francesca has time towards the end to talk a little bit about that. But we do want and encourage you all to please let us know the types of things that you do want to hear about. Either after you've watched this video series, you can always come in and open up an issue and say, hey, could you add some information about this or make a series about this? Or even just during the stream, if there's something in particular you're super interested in, Francesca and I would love to know. Awesome.
Yep.
Great. So I'm going to pass it off to Francesca now, who's going to talk a little bit about machine learning at a higher conceptual level. And like I said, these slides we'll make available to you after the stream. Let's see. Where will they find them, though? Probably the best place is I will add them to our Reactors repository, which you'll be able to find here. Here, we'll add them to this README here. So I will be sure to add Francesca's slides to this README in case you can't see them because of my low bandwidth. Again, I apologize for that. And let me make sure, perfect, your slides look good. And let me just make sure, so for some reason, OBS likes to resize Francesca's camera, but now that's looking better. So I'm going to pass it off to Francesca so that she can tell you, again, a little bit more of a higher level conceptual understanding of what machine learning algorithms are and what AutoML is.
Yeah, thank you so much, Sarah. And also to answer the previous question on the neural network. As Sarah said, we are not tapping neural networks in general during this live stream and also during the video series. We started with a more classical type of machine learning algorithms. However, I would love to talk about different type of neural networks and how you can use them for your own problems. So I'm sure that Sarah and I actually are going to work on this, and we are going to create additional content in the future because it's a tool that, of course, as a data scientist, machine learning scientist, we use all the time. So just to get started with this part, we are going to understand different machine learning algorithms. The first question that you should ask yourself, and that I get actually this question very often, is what is machine learning and how I can use machine learning. So machine learning is a subset of artificial intelligence, of AI, and it uses different techniques such as also deep learning. So deep learning is actually a subset of machine learning, and these techniques enable use experience, so experience from the past. This is what we call the to improve different type of tasks in the process. So this learning process is most of the time based on three different steps. We have the first step is data preparation. So usually you prepare your data, and before even preparing your data, you have to know a little bit the type of data that you have and how you can use this data to feed an algorithm. So in this step, basically you provide an additional information to the model, for example, by performing a feature engineering or feature extraction. Then you use this data to train a model, and then you test and deploy this model. At the end, another important step is also you have to make sure that this model can be consumed by other people. So the operationalization part is also very important, and there are many different tools that you can use in order to automate this process, such as MLOps or machine learning pipelines. And again, we can talk about these later if you have any questions. As you can see from these slides, with machine learning, you can actually do multiple things, and it depends a lot on the type of data that you have and on the type of question that you want to answer. You can predict between different categories. You can understand images and natural language. It is very, very close to the area of AI. You can discover partners in your data. You can predict the results based on the relationship between the values. This is more like related to regression or time series forecasting scenarios. So again, you can do a lot of things, but after that you understand a little bit better what's machine learning, it's also important to understand what are the different typologies of machine learning algorithms that you can use. And this is another popular question that I get very, very often, which is which algorithm, machine learning algorithm should I use? The algorithm that you select depends a lot on the type of questions that you are trying to answer. And so it depends a lot on your data science scenario. What do you want to do here? What's the business question that you want to answer by learning from your past data? As you can see from this spreadsheet, and by the way, you can download and use this spreadsheet for your own solutions. You can find it at aka.ms/algorithm cheat sheet. I put the link here at the top. So as you can see from these, there are different type of answer that you can give to yourself based on the different data that you have and based on the different scenarios that you want to use for your data science solution. For example, you can predict between different categories. You can predict between two different categories. This is a classifications or multi-class classification. You can classify images, generate recommendations. This is the family of the recommender systems. You can discover structure, find unusual occurrences, predict values. This is more like a thing. And finally, extract information from text. So as you can see, these are all the big families. Under each family of algorithms, you have different topologies of algorithms. And remember in the question that they asked us before, like, what about deep learning? Deep learning is using one of these families. Is a family of neural networks, but also in deep learning there are many different categories of neural networks. And again, I will be happy to discuss these more offline or to create additional content in the future. After that, you get an understanding of what's the type of question that you want to answer, and as a consequence, what's the type of algorithm that you can use to answer that specific question. Another important factor to consider is actually what are the different requirements that are important for your solution. So these are a sort of, I would say, sort of requirements and somehow some sort of limitations that can still be very, very helpful because they can drive you to, again, pick the best algorithm for your data science scenario. As you can see from this slide, of course, the first step is still what you want to do with your data, and you can use the algorithm cheat sheet for that. But let's say that you want to understand better what are the different requirements that you should still keep in consideration. You can look at aka.ms/select algos. This is a document, a pretty technical document that shows you how actually you can take in consideration factors such as accuracy, training time, linearity, number of parameters, and number of features. So accuracy, let's quickly go through all of them so that you can get a better understanding of what these terms are. Accuracy in machine learning is usually a metric that is used to measure the effectiveness, I would say, of a model as the proportion of true results to total cases. In machine learning, specifically in Azure machine learning, and also in what we call the designer, we have the evaluate model module that for you, it can compute different industry standard evaluation metrics, and you can use this module to measure the accuracy of your trained model. So every time that you start your data science journey, you have to think about accuracy and what's the accuracy that you want to reach. Training time is very important, specifically also in supervised learning. So training means that you use historical data to build a machine learning model that somehow is able to minimize errors. So the number of minutes, for example, or sometimes even hours that is necessary to train a model for sure is different. And it's a great factor that, in my opinion, you should look at because training time is often closely tied to accuracy. So it's important, again, to for sure have algorithms that train themselves, but sometimes you want to avoid algorithms that take a few hours to train themselves. Linearity is another important factor. In statistics and machine learning means that there is a linear relationship, as the name says, between a variable and a constant in your data set. For example, linear classification algorithms, they assume that classes can be separated by a straight line. And there are different examples of machine learning algorithms that actually have this property, such as multi-class logistic regression, two-class logistic regression, support vector machines as well. Then the number of parameters. Parameters are numbers that affect an algorithm's behavior. So it's very important because somehow they are the characteristic of an algorithm and they affect how the algorithm is going to perform. Some example of parameters are the error tolerance or the number of iterations or the different options between the variants of how the algorithms behaves. So the training times and accuracy of the algorithm can sometimes be very sensitive to getting just the right setting. And it's important, again, that you iterate multiple times and you try different parameters for your algorithms to find the best solution for, again, your data set and your data science scenario. Finally, I want to mention also the number of features. So also this is a very, very important to keep in mind. As you all know, in machine learning, a feature is a variable that is a variable of the phenomenon that you're trying to analyze and to understand. And for certain types of data, the number of features can be very large compared to the number of data points. So this is actually a typical case of genetic data or textual data. And a larger number of features can, I would say, slow down also some learning algorithms because it can make the training process very, very long. So on one side, of course, having multiple features can be very, very good because you can understand better your data and they can learn, the model can learn better. However, having also too large, I would say, number of features can also slow down the training process. And so sometimes it's not the best choice that you want to make. As you can see, so there are different things that you should keep in mind after that you start with the question, what you want to do with your data. And in the last, I would say, couple of years, another important technique that actually has been developed and used a lot by data scientists and also by researchers at Microsoft is called automated machine learning. If you want to learn more about automated machine learning, you can look at aka.ms/automatedml. So it's important to understand that automated machine learning, and it's still an area of research, and somehow is a way for data scientists to learn more and have a second opinion on how they can pick the best model for their data science scenario. In this case, they're using automated machine learning on Azure Machine Learning, and we will see very soon how you can access that. So what's the typical example of a machine learning problem? So let's start with a machine learning problem example. So let's say that you want to understand how much is this car worth. So understanding the predictive power of a set of features with respect to a dependent variable is a very tricky problem, and I would say that there is no universal metric which can tell you exactly how to do that. So as we saw from the previous slides, the answer is always it depends. It depends on the type of data that you're using, the size, the quality, the nature of your data. It depends a lot on what you want to do with your data. But I would say most of the time, data scientists and more generally speaking, the data science team, they just sit together, and what they do is that they try to answer these three specific questions: which features, which algorithm, and which parameters should I use in order to build the best machine learning model to answer my question. And in this example, the question is, how much is the cost of this car, for example. Model creation is typically very time consuming because you sit down as a data scientist or as developers and you pick a few features such as, let's say, mileage, car brand, year of make, and then you can select a different type of algorithms. Let's say you select the gradient boostant, and then also you select a different type of parameters. As you remember, parameters are different type of characteristics that can influence the behavior of your machine learning model. And let's say that you get the first model that is accurate until 30%. So it has an accuracy of 30%. And then again, you keep doing these multiple times. And as you can see, this is a very long, I would say, time-consuming process. You eventually pick a different type of features, different type of algorithms, and eventually you get a little bit better model. And so data scientists, they do this all the time. So they try different type of features, different type of algorithms, and different type of parameters to try to eventually get to a model that is pretty good. In this case, in this example, I put a 95% of accuracy. That is actually very, very good for a machine learning model. So as you can see, it's very, very iterative and long process. And this is only for the selection of the machine learning algorithms. There is something else that I also mentioned before that is called also a hyperparameter selection, which is again another very iterative process because, as I mentioned before, hyperparameters are higher level parameters that cannot be learned directly from the data using, for example, a gradient descent or other optimization algorithms, but they describe more like a sort of structural information of your model. And basically the only way to understand what are the best parameters for your models is really just try them manually. So again, as you can imagine, imagine a model selection and hyperparameter selection is a very time-consuming and iterative type of process. That's why data scientists and Microsoft research scientists came up with this automated machine learning feature, which is again within Azure Machine Learning. And Sarah and I shows you, like during the video series, how you can access it and how you can use this feature not only from Azure Machine Learning, but also using Python in VS Code, in Visual Studio Code, for example. So it's a feature that really you can use from different places on Azure. And so automated machine learning is really a way to automate the time-consuming and iterative task of machine learning model development. So basically, data scientists, analysts, developers from different type of industries can use automated machine learning to save time and resources. I would say this is the first thing that is great. And then they can also leverage data science best practice. And then, of course, they can also provide agile problem solving, because again, you're going to see a list of best models for you, for your data set and for your data science scenario. For now, automated machine learning supports classification, regression, and time series forecasting. So this is actually, I would say, a large part of different type of data science scenarios, and so it can really help you with the development of your solution. Um, uh, just to give you an overview of what are the different characteristics of automated machine learning on Azure. As I said, there are three different tasks that right now are supported. These are classification, forecasting, and regression. The only thing that the data scientist needs to do is that they need to specify the source and the format of the labeled training data. For example, if it is an NumPy arrays or if it is a pandas data frame, then you have to to configure your computer target. This is another important part, because it can be your local computer or Azure machine learning computes, remote virtual machines, or also Azure Databricks. Again, it depends a lot on what your preferences are. And during training, the Azure Machine Learning Service creates a number of in parallel pipelines that try different algorithms and parameters, and it will stop only once it hits the exit criteria that are defined in your experiment. So you can tell automated machine learning if you want it to run for, let's say, for 10 different parallel pipelines, or 20 or 50. So you have total control of what automated machine learning is doing. Just to give you also some additional information on how you can learn how to build your auto ML config class. And again, you can find more about this both on the aka.ms/automated machine learning and on aka.ms/automl config-class. But here you can see that this is just a AutoML config class that represents the configuration that you need just to set up. So these are all the instructions basically that you give to automated machine learning. And then after that, you tell automated machine learning what you want. Basically, you start running with what you want. Like some example that I already gave you are like it is a classification, a regression, how many iteration you want, what's your performance metric, some of these sort of instructions. So here are some of the resources that I use during these short presentations. But as Sarah said before, all our resources are on the GitHub repo, and watch the 28 video series also to learn a little bit more. But as you can see here in these slides, if you want to learn more about the data science life cycle, algorithm cheat sheet, automated machine learning, Azure machine learning, and also how you can select the different Azure machine learning algorithms, you can also go to all these resources and learn by yourself. So let me know if you have any questions. Awesome. Sarah, back to you.
Well, back to us, and let me adjust your screen size again one more time. Thank you so much, Francesca. Your knowledge, her knowledge is exactly why I partnered with her on this project, because I really wanted to make sure that what I was getting was not only really great explanations, but also in a way that I could understand them. So I really appreciate not only your partnership on this stream and on the series, but also all of your efforts to improve our documentation around Microsoft as well.
Likewise, because I always learn a lot from Sarah. So, so thank you so much.
So we're gonna we've got about 15-20 minutes left, and I want to encourage folks to ask some questions in the comments section. But I did see someone post, data is facts and statistics collected together for reference or analysis, which I really loved that explanation. But I did want to challenge it a tiny bit on the word facts. And we do have one of our videos in the data science series that talks about ethics in data science and ethics in AI and things like that. And this idea of data being facts, that sentence tends to make me nervous, because data is really only what you, a human, gathered, right? And so even if you had a sensor, right? If you had a sensor that was gathering information on, I don't know, standing or sitting or something like that, and you put the sensor on me, who's a 5'1" person, and then you put the sensor on my partner, who's a 6'7" person. I think that's like 2 meters, and I don't know what 5'1" is, but it's a foot and a half. It's big difference. Let's just put it that way. I think that the sensor would register things slightly differently. And we've seen this with things like, pedometers to track your walking, and people who have longer strides and shorter strides, it tracks it slightly differently. Right. So with things like pedometers, like a watch or something that tracks your walking, if it's trying to track your number of steps, I used to always laugh because my mom would get so upset and she would say, I counted my steps and then I looked at it and it was not correct. And I'm like, okay, but you counted 15 steps, you looked at it and it said 13 steps. The point of it is not to say you walked exactly 5,231 steps. The point of it is to say, on days like today, you tend to walk around 5,000 steps. But on days like yesterday, you tend to walk only around 2,000 steps. It's not the number that matters, it's the around, so that you can kind of get an understanding of your habits of walking and moving and things like that. So with things like pedometers, generally, for the purpose of the problem that it's trying to solve, which is making people more aware of their walking and movement habits, it's fine that it's not super accurate. However, when we get into other parts of data and how we're gathering data, the mechanism for which we're gathering it, the conditions for which we put around it, and then we bring it into kind of the cleansing and manipulation, which is not to change the data, but rather to make sure that it accurately represents the world. And then we get into the part of using that as a piece to make a decision. There are a lot of places for human bias to come in. And so, one example that we use in the video series is, I think we use this one in the series, I can't remember now. But one example is if you were trying to classify, I don't know, here, let's just take a different example. I am doing an experiment on what foods my daughter likes to eat. And so I track everything.
Very nice.
I mean, I'm not really, but let's pretend I am, and I track everything that I put in front of her, compared to what she eats, how much of it she eats, and then how hungry or how happy or whatever she feels afterwards. And I notice that, if I put meat in front of her, she tends to eat a lot of it. And if I put cheese in front of her, she doesn't eat any of it, or something like that. I did not put every type of cheese in front of her. I did not put every type of meat in front of her. So if I make an all-encompassing decision that my daughter doesn't like cheese, but really she just doesn't like yellow cheddar cheese, but she loves Parmesan cheese, and I just never offered it to her, then I'm going to be making a decision that affects her nutrition or her, just exploration of new foods without the full amount of data, right? That seems like a trivial case, but that's really, really important, because if you're not making sure that the data that you're gathering is complete, then the answers or the knowledge or the conclusions that you're drawing from that data aren't going to be representative of everything. They're only going to be representative of the things that you collected the data for. And I talked a little bit about data manipulation and cleansing, and I want to give kind of insight into that, because when I first heard that, I was like, oh my gosh, how do you take real truthful data, because I had a misconception that data was truthful at that time, and then you cleanse and manipulate it? Like, really, you're just doing whatever you want to it to give me this answer. And yes, people can do that, and people do that, but we're not talking about that part of it. If you are truly doing data science, there is a part of data cleansing and manipulation. For example, let's say you're just taking weather data, and the point of this is to track, let's say, just kind of the temperature. Let's just make it super simple. The temperature of where your plants are going to grow, because you want to optimize for the types of plants that you grow in that garden, let's just say. And for 3 hours one day, and you take temperature once an hour, but for 3 hours one day, your sensor goes out. Let's say your sensor ran out of battery or something, and so it notified you right before it went out, but you didn't have a battery, so you had to run to the store, come back, replace the battery. Great, put it in. Now your sensor's gathering data again. But for those 3 hours, you don't have data. When we're running, machine learning algorithms on this, we want to make sure our data is complete. But if those 3 hours are missing, we have to make a choice. Do we throw out those 3 rows and say this data is not, we don't know the truth here, so we're not going to use this at all. It's not going to inform any of our decisions, period. Or do we say, okay, in 3 hours, the hour before it was 50 degrees, whatever, Celsius, Fahrenheit, make up whatever you want. It was 50 degrees. And on the 4th hour, it was 52 degrees. It seems like within those 3 hours, it wouldn't have gone to 80 degrees in 1 hour and then back to 50, right? And especially because you might have lived it, right? You might have been there and known that there wasn't any massive change in temperature. So you could reasonably say, I'm going to take the 1st hour and that 4th hour, and I'm going to average it out and make that the data for those 3 hours that are missing. That's a total reasonable data manipulation that you could do. Now, if you were doing that regarding like an action movie, so you're trying to see how many people are watching a certain movie or certain types of movies, and you gathered the views from action movies and the views from romance movies and the views from whatever, and you're not only going to say the different types, but also which movies performed well, and you forgot to gather data on this particular movie, no, it's not reasonable to take all action movies and take the average of those and add it to that movie, because that movie might have just been horrible, or maybe nobody wanted to watch that movie, right? And so you would be giving an inaccurate representation of that movie. And that's a moment where, I'd be like, let's just throw it away. Let's cleanse this data. Let's throw that movie away. So I just want to caution everyone around the idea of data being facts, because while the number on the sensor might be accurate, and, let's not take into account the fact that the sensor might be defective. Let's just pretend like it's not. The number coming from the sensor might be accurate. What we're gathering, how often we're gathering it, taking into account that we live in the real world, and so sensors will go out, or you'll miss a day or something like that. Taking into account that a bug might sit on it and make it warm. I don't know. Taking those things into account, those real things into account. That's why the cleansing and manipulation of data, that step, is also extremely critical. And that's why the collection step and understanding what you're collecting and why is extremely critical. And then when you're writing the algorithms and choosing the algorithms, choosing which ones will accurately represent the data and analysis of the data that you have is extremely critical. So all of it is very, very, very important. So I just wanted to kind of challenge that. Francesca, do you have anything else to add while I read the chat?
No, absolutely. And I love, Sarah, your examples, because I think they give a sort of a realistic perspective of, what data science is, how you can use data science to build your machine learning solutions. And most importantly, you also mentioned the risk of data science by mentioning all these examples. And I want to mention that in the video series, we have two videos. One video that I really suggest to all of you to watch, that is about ethics in data and in data science. And Sarah, in my opinion, gives a wonderful overview of what are all the different risks, but not only, what are all the different questions that you can ask yourself while you are running your data analysis. And eventually this can give you a better perspective of how you can make sure that you're also making ethical choices once you're building your solution. And the other video is about how you can implement those decisions, those insights into your machine learning solution using a few toolkits that are open source toolkits. However, they are also available on Azure Machine Learning. And so this is the interpretability machine learning toolkit. So this is, again, a Python code that you can use to understand better what your machine learning model is doing and why it is producing specific type of results. So I really, really like these, lenses that Sarah, you're using to look at data and data
Definitely.
science.
We got a really great question, an example of business case and how we would translate that to the thought process, into machine learning. One of the first few videos we do in our series is around this. I'll kind of like redo that one, and then Francesca, if you have another one, you're welcome to share. But in this case, it was a bike sharing app, and so I'm building an app where, frankly, I want to make more money. I want my bikes to be more used, because that means I'm providing an positive influence on my community. But also, let's be realistic, I wanted to make more money, which means I need my bikes to be used more often. So that's kind of where you start, right? You're like, okay, what is my really high level goal? I want to make more money. What's my next high level goal from that? How will I achieve that? I need more bikes to be rented. Okay, it's then how do I what might allow more bikes to be rented? I could go one route and just buy a bunch more bikes, but and not do any kind of machine learning, just kind of throw them everywhere. Sure, I could do that. But let's say I don't have any more bikes. The next thing I could do is I could start to understand how many bikes are likely to be rented on a particular day. And if I did this by location, so in the video series, we just did that kind of all up, but let's pretend like I split it by location, by zip code, or by part of town, or whatever. Then what I could do is, for this part of town, I could see Tuesdays are a really great day for bikes being rented. 90% of my inventory gets rented on Tuesdays in this location. And 80% of my inventory gets rented on Thursdays at this other location. Then what I could do is, on Monday nights, I could take my inventory from one location and move it to the location where 90% of my bikes are being rented. Because I could reasonably assume that if a lot of my bikes are being rented, that if there were more available, more bikes would be rented, right? And so in this case, what I'm trying to do is predict in a time series how many, or predict the likelihood or the amount of an event happening. And so we used a time series forecast algorithm to be able to do that. So similar to what Francesca showed on the what do you want to do, the algorithm cheat sheet, which we linked both on the screen in the YouTube series, on the GitHub repo, and in the chat. That algorithm cheat sheet kind of helps you start to understand, okay, what is it that I really want to do? Right? And so if what you want to do is to predict between two different categories, is this a cat or is this a dog? If you want to do that, then you might want to use a two-class classification system, right? And then we can kind of go into more details to that. Is it a decision forest? Is it an average perception? Like, which one is that? And there's different kind of classifications around there. If you're trying to say, something always tends to happen, but there's an unusual thing that happens every once in a while, and I'm trying to be able to detect when that unusual thing might happen, that might be an anomaly detection type algorithm, right? If you're trying to simply extract information from text, that is still a data science question or a data science problem, because you have lots of data, meaning lots of text, and you want to try to extract information from it. And so you can use things like feature hashing or pre-processed text or word Z vector. I'm not super expert in all of these. But basically, that algorithm cheat sheet is one of the ways that you can start to figure out which type of algorithm you'll want to use. And then from there, you'll start to figure out like which exact algorithm and what parameters and what featurization and all of that you might want, or what features and all of that you might want to specify. Do you have another concrete example, Francesca? You might not. I'm throwing you on the spot, but another concrete example of a machine learning business question?
Uh, yes, so another example that really comes from the business world is sales
Mm-hmm.
forecasting. So let's say that you are working with the customers that has stores all across the United States, and for some stores they realize that they have enough supply. For other stores, they do not have enough supply. So they come to you and they're like, okay, these are our transactions data. We want to understand better how we can optimize our source, the inventory in our stores. As you can imagine, this is a very, very popular scenario. And the first things that you have to do is actually predict the
Mm-hmm.
demand. So understand better what are the different requests from different customers and what's the time that these requests are going to be collected somehow, if it is an in-store type of purchase or online purchases. And let's say that you have all these data. So you really try to estimate how many products per product
Right.
ID. So of course you have different type of products are going to be done. For example, how many of these products are going to be purchased in a specific,
Yeah.
let's say, hour. And again, this is similar to the bike forecasting. Is different in the sense that in this case you have to analyze different
Mm-hmm.
geographical variables, but also product variables. But it's still a time forecasting type of scenarios. So you start to understand, okay, if I want to optimize an inventory, I also need to get how much demand I'm going to have for that specific
Right.
store. And I can use also external data, for example, weather or other economic indicators can be very important in this case because they can affect the demand.
Right.
And you start again building your first time series forecasting. In this case, again, is demand sales
Yep.
forecasting, and you translate that in a type
Yep.
of regressions. So as you can see, the flow is very similar to the flow that Sarah shared with us. We start with a business question. We start to understand what are the different steps that you need to take in order to answer that question. And then you start to understand what are the different
Mm-hmm.
data sets. So not just the transactional data set about sales, but also eventually weather data, economic indicators that you can use to improve your
Yep.
model. And in this journey, you actually translated a business problem into a data
Yep.
science question.
Exactly. So we're just about at time. I did want to mention that we do have more streams coming up the next 3 days, as well as next week, Monday, Tuesday, Wednesday, Thursday. We have all of these streams that are going to be covering different machine learning and data science topics. So tomorrow we have an introduction to Azure Machine Learning Designer. And in fact, Cassie's going to be talking about 3 ways to solve the same problem. On Thursday, it's going to be getting more Instagram likes with machine learning. I'm going to be, like I mentioned, doing a 2-hour stream on Thursday around financial data and how to integrate it into, or, do essentially this data science lifecycle. On Monday, Francesca is going to be interviewing someone from Azure Machine Learning to kind of give you an understanding of that tool and service. On next Tuesday, it'll be do it all with Azure Machine Learning. So this is another just kind of like overview of lots of different features from Azure Machine Learning. Automated machine learning reduces times to insight on Thursday, and then 8 different machine learning examples the following Thursday. Or I said Wednesday, so the following Thursday. We will stick around in the chat for a little bit to answer some of the last minute questions. But I also would love it if you could please fill out our survey. The survey is at aka.ms/reactor feedback. The survey is anonymous and very, very useful for us because it helps us understand what content you want to see rather than just us guessing and creating content we want to make for you. So please fill it out so that we can make better content for you. Also, this stream and all of our other streams will always be on the Reactor YouTube channel every Friday evening after the stream has run. So that's at youtube.com/Microsoft Reactor. And again, the content from today is on our GitHub repo. So with that, Francesca and I will stick around in the chat for a little bit, but thank you so much for joining us, and see you again later this week.